AIRSHIP's Air 3L tactical drone and Hive platform, it is developing an AI voice orchestration system for real-time two-way communications with multiple autonomous tactical drones. This AI multi-agent voice orchestration C2 command and control agentic communications is AIRSHIP's conversational swarm supervisor. The AI and machine learning system uses decentralized AI drone mesh network nodes and natural language processing to let a single operator have interactive situation report communications with drones while directing large autonomous drone groups during combat. The goal of this AIRSHIP voice orchestrator is to allow a single operator without special training to give broad commands and have one-on-one dialogue with a whole group of uncrewed vehicles that not only talk with the commander, but also with the drone swarm participants under command. What you will hear are 5 scenarios where the commander is speaking to and conversing with drone squads and the AIRSHIP Hive launcher and recovery platform.
All units lock frequencies. We have a massive hostile swarm inbound at 0800 yards. Drones 1 through 15 switch to autonomous swarm intercept geometry. Protect the aircraft carrier at all costs. Mission assumptions are as follows. Commander, 1 U.S. Naval Commander. Force, 15 AI-enabled Air 3L tactical drones, enabled with dual turret directed energy blue lasers, and 6 Air 3L tactical drone replacement spares nestled in the Hive. Launch platform, fast robotic boat with mounted AIRSHIP Hive launcher. Threat, hundreds of swarming hostile drones. Here is the voice orchestration from the commander and each drone under command. Scenario 1 drones respond. Drone 1, frequencies locked, commander. Target grid accepted. Activating blue laser emitters. Drone 2, cluster 1 engaged. Firing energy beams now. 3 hostile targets neutralized. Drone 3, swarm density is heavy at sector 4. Shifting power to cooling systems. Drone 4, target handoff complete with drone 5. Laser tracking is steady. Drone 5, confirmed. Target destroyed. Adjusting altitude to clear backblast. Drone 6, energy levels at 90%. Continuing continuous wave sweeps. Drone 7, hostile trajectory predicted. Intercepting vector on lead enemy cluster. Drone 8, for hostiles down. Swarm formation is breaking apart. Drone 9, thermal limits stable. Maintaining lock on high-speed bogies. Drone 10, rerouting power from propulsion to optics for deeper range view. Drone 11, clear path for Drone 12. Sweeping the lower flank. Drone 12, flank secure. Laser hits verified on multiple incoming signatures. Drone 13, enemy density decreasing in our sector. Assisting Drone 2. Drone 14, last wave of primary threat cluster is burning out. Drone 15, all immediate local targets neutralized. Awaiting next directive. Commander follow-up. Commander, outstanding work, drones. Hold defensive perimeter around the carrier until the skies are completely clear. Report any drop in battery or optics.
Orchestrator technologies must allow people to work the way they already command, through plain language that expresses desired effects, constraints, timing, and priorities, not by clicking through menus or programming behaviors.
Scenario 2, AI orchestration and coordination. Commander, all units, clear for autonomous network mesh. The hostile swarm is too dense for manual targeting. Drones 1 through 15, initialize distributed edge compute tracking. Protect the carrier. Orchestrated swarm defense now in effect. Drone 1, network mesh anchor, network synchronized. Establishing local edge mesh across all 15 drone network nodes. Hostile swarm count is now at 422 hostile bogies. Starting to allocate threat vectors. Drone 2, receiving target allocation matrix. Node 2 through Node 5 taking the western approach vector. Drone 3, tracking 45 bogies at 12 o'clock high. Blue laser array is primed. Deconflicting firing lanes with Node 4 to avoid beam crossover. Drone 4, lane deconfliction confirmed. Laser firing in microsecond pulses. 12 targets neutralized. Passing residual track data to Node 5. Drone 5, picking up residual tracks. Kinetic energy calculations are complete. Thermal load on blue laser emitter at 40%. Drone 6, dynamic backup. Node 7 has experienced temporary sensor glare. Rerouting my tracking data to fill its blind spot. Drone 7, data received. Node 6. Optical correction applied. Resuming blue laser sweeps on the central swarm cluster. Drone 8, predictive AI models show enemy swarm shifting to a pincer formation. Initiating dynamic geometric split. Drone 9, splitting now. Moving to high altitude covering angle. Initiating continuous wave burn on lead enemy elements. Drone 10, detecting electronic jamming from the hostile swarm. Switching mesh communication to optical laser relays. Drone 11, optical mesh stable. Node 11 through Node 15 forming a low-altitude defensive wall for the carrier's hull. Drone 12, target saturation reached in Sector Bravo. Requesting energy pooling support from Node 13. Drone 13, acknowledged Node 12. Adjusting my top and bottom gimbal mirror sensors. Cross-firing blue lasers to multiply thermal impact on heavy targets. Drone 14, hostile swarm numbers dropping rapidly. Remaining threat count at 32 bogies. Recalculating power grid distribution. Drone 15, power optimized. Final sweep initiated. All node systems reporting nominal status. Network wrap-up. Drone 1, mesh anchor, hostile swarm neutralized. Perimeter secure. Transitioning mesh from combat geometry back to standard patrol loops. Commander, solid copy, mesh leader. Hive launcher is ready on the robotic boat for drone retrieval. Stand by for Hive autonomous battery, ultra-fast battery charge, where needed. Scenario 3, malfunctions and glitches that the AI network fixes on its own. Commander, all units stay sharp. Massive electromagnetic pulse, EMP, detected from the enemy cluster. Multiple system anomalies expected. Let your onboard AI, NVIDIA processor, engage, adapt, and self-heal. Protect that carrier. Glitch and self-healing log from drones. Drone 1, mesh anchor alert. EMP impact has corrupted my primary routing tables. I am losing connection to nodes 02 through 05. Initiating decentralized token passing to prevent total mesh collapse. Drone 2, data link severed from Drone 1. Logic circuits intact. Activating local consensus protocol. Voting Drone 3 as temporary submesh anchor. Drone 3, submesh anchor role accepted. Redundant memory banks loaded. Relinking with Node 04 and Node 05. Resuming laser tracking. Drone 4, glitch detected. Thermal sensor on my blue laser is reporting a false maximum temperature loop. My safety lock is freezing my weapon. Initiating a hard firmware rollback while in midair. Drone 5, Node 04 is defenseless during rollback. Shifting my physical position by 10 meters to cover Node 04's defensive lane. Firing lasers at maximum pulse rate. Drone 4, rollback successful. Sensor calibration restored. Blue laser active. Thank you, Node 05. Resuming combat duties. Drone 6, hardware fault. Left stabilization motor number 4 has ceased due to shrapnel. Losing altitude rapidly. Drone 7, calculating flight physics for Drone 6. Rerouting power to your remaining 3 rotors at 120% capacity. Change your tilt angle by 8 degrees to compensate. Drone 6, tilt angle adjusted. Flight path stabilized on 3 of 4 rotors. Laser aiming matrix recalibrated for the offset tilt. I am back online. Drone 8, optics failure. Top mirror gimbal is stuck at a fixed 45-degree angle. Cannot sweep the target grid. Bottom mirror gimbal still functional. Drone 9. I see your position, node 08. Do not move your gimbal. I am bouncing my blue laser beam off your fixed mirror to hit targets behind the carrier. Shared geometry active. Drone 10. Buffer overflow in enemy threat tracking database. 100 plus phantom targets appearing on my screen. Real-time radar data is corrupted. Drone 11. Cross-referencing your radar data with my clean optical data. Filtering out the digital ghosts. Sending you a clean target map now. Drone 12. Battery cell rupture on my main power pack. Total system shutdown imminent in 40 seconds. Drone 13. Initiating emergency wireless power transfer. Flying into close formation docking range. Keep your receiver open. Drone 14. Power bridge established between node 13 and node 12. Node 12 power stabilized at minimum operating limits. Both lasers still functional. Drone 15. All self-healing loops complete. Mesh network structural integrity restored to 94%. Final hostile wave is burning out. Status report. Drone 1. Mesh anchor main routing tables rebuilt. Resuming full network command. All 15 units accounted for. Swarm completely destroyed. Commander, incredible self-recovery team. That is what I call a resilient network. Hive boat is holding position for automated recovery and repairs. Scenario 4. Robotic hive boat launches drone replacements. Commander, nodes 6 and 12 are taking heavy damage. Their power grids are too low to sustain the mesh. Robotic hive boat Beowulf, activate Spare's emergency rapid launch protocol. We need fresh wings in the sky now. Hive boat launch and AI voice orchestration dialog. Hive boat Beowulf, launch Spare side bay doors opening. Pneumatic pressure at peak. Pre-initializing fully charged blue laser systems for replacement nodes 16 and 17. Drone 1, mesh anchor network alert. Node 6 and node 12 are dropping out of the combat geometry. Open slots detected in the defensive perimeter. Hive boat Beowulf, node 16 launched from Hive Store Alpha. Node 17 launched from Hive Store Bravo. For Spares remain and fast tracking ascent vectors. Drone 16 replacement mid-air ignition successful. Rotors at maximum RPM. Scanning for the mesh beacon. Drone 17 replacement high pneumatic propulsion booster separation complete. Switching to drone battery power. Blue laser array initialization sequence is green. Drone 1 mesh anchor new nodes detected. Welcome to the mesh 16 and 17. Downloading active target matrix and threat vectors directly to your NVIDIA processor edge compute core. Drone 16, data received. Locking onto the northern enemy cluster. Firing blue laser pulses now. Drone 6, damaged node. Drone 16 has assumed my sector responsibilities. Initiating autoglide back to the Hive boat recovery deck. Hive boat Beowulf. Drone 6 captured by the Hive's magnetic landing grid during fast boat transit. Beginning automated ultra battery recharge and drone structural damage assessment scan. Drone 17, vector clear. Heavy enemy drone destroyed. Coordinating laser crossfire with node 14 to sweep the remaining threat corridor. Drone 12, damaged node power at 2%. Dropping below the engagement zone. Landing safely on Beowulf's magnetic recovery store Bravo. Hive boat Beowulf, drone 12 secured. Commencing laser mirror realignment. Replacement drone 18 is now queued in Hive store launch position if needed. Drone 1, mesh anchor, network balance restored. Mesh health back up to 100%. The remaining hostile swarm is scattering. Mission complete. Hive boat Beowulf. All local airspace cleared of hostile signatures. Hive launcher returning to standby mode. Commander, brilliant coordination, Beowulf. All replacement drones hold high patrols until recovery rotations are finished. Carrier is safe. Scenario 5, landing and recovery process on fast robotic boat. Commander, team, excellent work out there. The sky is clear and the carrier is safe. Robotic hive boat Beowulf, activate the recovery protocols. Bring our drones home for maintenance. Automated landing and recovery sequence. Hive boat Beowulf. Recovery deck active and boat speed slowing for drone retrieval docking. Initiating the drone magnetic landing grid. Extending Hive micro hanger hydraulic capture rails to recover drones. Ready for Node 1. Drone 1. Mesh anchor, copy that, Beowulf. Handing over local airspace control to the boat's landing computer. Node 1 initiating descent. Hive boat Beowulf. Node 1 captured on micro hanger retrieval rail arm. Securing the chassis. Moving Node 1 into the internal micro hanger repair bay. Drone 2. Entering the landing pattern behind Node 1. Adjusting for the boat's speed wake. Hive boat Beowulf. Node 2 secured. Locking the landing rails. Commencing automated battery ultra-fast charge. Time to completion, 12 seconds. Drone 3. My optics are still hot from the combined beam strike. Requesting immediate return bay air cooling flush upon touchdown. Hive boat Beowulf. Request approved. Node 3. Micro hanger rail is cooked with liquid nitrogen cooling lines. Land now. Drone 4. Node 4 through Node 8 are forming a landing queue. Battery levels average 15%. Drone 5. Winds are picking up across the ocean surface. Adjusting drone rotor pitch and speed to maintain steady descent vectors. Drone 6. This is the repaired Node 6. Flight physics stable on 3 rotors. Ready for Hive Space Command's virtual comms mechanical inspection. Hive boat Beowulf. Scanning Node 6. Structural damage detected on the left wing. Robotic repair rails are queued with temporary wing repair appliance, where practical. Drone 7. Node 7 is down. Magnetic grid lock confirmed. Drone 8. Node 08 is down. Safely locked in a Hive micro hangar. Drone 9. Node 9 through Node 13 entering the lower holding pattern. Drone battery power levels are nominal. Drone 10. Initiating data dump. Transferring all telemetry and threat logs to Beowulf's main server and the cloud. Drone 11. Node 11 is down. Disengaging and recharging laser weapon systems. Drone 12. Node 12 is down. Ready for mirror sensor realignments. Drone 13. Node 13 is down. All internal systems switching to standby mode. Drone 14, replacement nodes 16 and 17 are the last units in the air. Clear to land. Hive boat Beowulf, clear to land. Nodes 16 and 17. Landing stores Delta and Echo are open. Drone 15, node 15 is down. The entire 15-unit mesh is inside the Hive. Post-recovery status. Hive boat Beowulf, all 15 tactical drones are securely nested. Launch micro hanger stores and rails are sealed. Diagnostic check shows 100% mesh network survival. Beginning full drone and laser recharge and laser mirror cleaning. Commander, copy that, Beowulf. Great job managing the deck. Secure from combat stations. We're heading home.
This concludes the Hive and Air3L tactical drone flight operation scenarios. And seen here is the Airship Voice Orchestration Process Map. Airship's voice orchestration system development must be capable of understanding and executing common military commands. While the explosion of large language models has revolutionized AI's ability to communicate with humans in plain text, voice communication is still evolving. This innovation pushes the envelope even further by having real-time two-way communication among the operator and the authorized mesh network of drones. Do spend a moment examining the process map. Thank you.